This is the Amp Hour Podcast, released July 31st, 2025. Episode 699. CircuitHub 12 years later with Andrew Seddon. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Andrew Seddon of CircuitHub.
Welcome back 12 years later. How you doing?
I'm good, Chris. Yeah, really good. I can't believe it's been so long.
Time marches on, and you have been busy. We were talking a little bit before the show, just like if you go back and listen to episode, actually, Andy reminded me to look at this, 131. So that's a couple episodes ago. You kind of had a different product and different thing back then. I've obviously watched you kind of keep going and watch CircuitHub keep developing over time. But can you tell us first what it was back then and then what it is now?
Yeah, I mean, we've been through a few different iterations at CircuitHub. I mean, when I think last time we spoke, our idea was to be a crowdsourced library for EDA data. So, this comes from my background as a design engineer. I kind of always thought it sucked to have to generate the symbols and footprints for any design that you were working on. I kind of just wish that there was this centralized cloud library that you could pull from, and you can avoid all of that additional effort. And so the first iteration of the idea was that we'd have this website, everybody could contribute their symbols and their footprints, and we could sort of crowdsource validations for those, and people could download them to their local EDA tool. And I think about around the time that we spoke last, we had probably just launched that product, and it did okay. The big learning there was people want the work done for them, but they don't particularly want to contribute to this shared library. And so we had a bunch of people saying, "Hey, this is great! We'd love to use this product once the library's fleshed out, but we actually don't necessarily want to spend the time contributing to the library." And so. So we we'd always imagined really CircuitHub as the EDA library was the starting point, and that we were going to go and fix manufacturing, right? So we had this idea that we'd acquire a bunch of users via the EDA library, and then we'd go off and make it much easier to manufacture circuit boards. And so we kind of half pivoted, but I would say it was just a natural extension of what we already did into electronics manufacturing. And so we've been through a few different iterations on that model. The way that we started really was with a sort of network of other people's factories. So we made it super easy to upload the design files for your circuit board. We would give you an instant quote from 1 to 10,000 units. So we give you a lead time, give you a price. You can click a button, pay by credit card, and we then get those boards made for you and sort of ship them out. And so we operated that model for a few years with this network of factories. And we actually ended up getting super close to a company on the east coast of the US, Worthington Assembly, which, funnily enough, to kind of close the loop on our first conversation, Chris, I think I was introduced to the CTO of that company, Chris Denny, by you after our first podcast all those years ago. So I think after that,
yes, I've come to collect.
Indeed, yeah, definitely. That's been an awesome relationship in sort of many different ways. So we've really got you to thank for sort of setting up that relationship in the first place.
We should also mention Chris. Chris is, you can hear Chris every week, every month. I don't know how often it is, but the Pick Place podcast. That's what him and I forget his co-host name. Sorry,
that's weird. Melissa as well. Yeah.
There you go.
Works on our marketing team.
Yeah, great. And and that's a great podcast as well. Like Deep, I just remember like board cleaning was like one of the episodes I listened to. I was like, oh, board cleaning. No, it's multiple episodes, I think. It was like board cleaning. Oh, okay. Yes, I do need to hear this actually. So we'll link that down below too.
Yeah, it's kind of Chris gets a bee in his bonnet about some particular niche aspect of manufacturing, and and then goes on a rant about it. It's pretty fun to listen to.
But that's what I want. I want to like hire experts, who care about circuit boards being seamlessly sent to manufacturing, or manufacturers that are seamlessly cleaning board. I don't I don't want to think about this stuff. I just want it to show up and someone to be thinking about that. It's great. That's really great. So, and I will listen to it. I'll listen. I'll be a voyeuristic listener. Just be like, yeah, that sounds like a tough problem. Glad you solved that. So, what
Yeah.
kind of in the midst? And speaking of tough problems, I mean, like, all of these things you've mentioned that CircuitHub's been doing over the years, none of them have been easy. I would say the library thing's still not really solved. Sort of, kind. I mean, like, there's other solutions that are out there, but they're all kind of still, like, we've had guests on the past that are doing it, but it's not like, it's just, there's so many parts out there. Manufacturing is not getting any easier. So, what have you been doing to solve all these problems, man? Like, it doesn't seem easy.
Yeah, I mean, I kind of jump forward a little bit to where we are today, maybe, which is we have essentially had a ground up rethink of how electronics prototyping and small batch manufacturing should be done. So, we started off with this network model on top of other people's factories. We actually set up our first wholly owned factory back in 2017. We did it using pretty common off the shelf equipment. We wrapped that up in a bunch of software, and we made some process improvements doing that. But it gave us a bunch of ideas about how we could really just go back to first principles and think about how could we make a super efficient prototype and small batch electronics facility. And so for really about the last 6 or 7 years, that's what we've been doing, is kind of we just had our heads down, doing this ground up rethink of how to do manufacturing. And so where we are today is we have this fully vertically integrated system on the east coast of the US. And a good way to think about it is a little bit like a semiconductor fab. Like, have you ever seen kind of videos of like the Intel fab or like TSMC? We've taken a lot of the techniques that originate in semiconductor fabrication, which is like one of the most advanced manufacturing processes on the planet, and then we've applied them to the assembly side of the and the fabrication side of the operation. And
Does that mean you have FOOPs? Because that's one of my favorite words.
FOOPs, yeah, we don't actually do it directly with FOOPs. So conceptually it's very
Ah,
similar to a semiconductor
got it,
fab,
got
but the
it.
actual
Darn.
problem is quite different. But they are cool, right? Those things dropping out the
Yeah.
ceiling and
That's
kind of throwing
front
things from A to
opening
B.
unified pod, FOOP. uh,
So
yeah.
it's an interesting problem. I mean, semiconductor manufacturing has some pretty different requirements to board level assembly,
Mm.
right? I mean, one thing is that the products that you're handling are like very uniform because you're dealing with
Yeah,
a
good point.
semiconductor wafer, right? So it kind of looks the same every time. Whereas in board level assembly, you're there's the theme that everything's on a circuit board, but in practice, those circuit boards can all look pretty different sizes,
Right.
shapes. They can have large components on them, big connectors and things that cause them to warp in all sorts of interesting ways. And so the mechanics
One,
of how you actually put that together are quite different.
well, I think just the number of input chemical. I mean, like, so you show up at so I used to work at a fab, and you show up at a dry etch station like I used to work at, and it's got RF energy and like 20 different chemicals maximum, right? But that's different than like, you know, 20 different types of boards in a day showing up to, a assembly station that needs, I mean, I'm guessing you just standardize and have all the caps are on one machine, all the resistors on another machine, that sort of thing. But like, still you need all of those different machines to have all of those different types of parts. So like that's still intense for that sort of thing. Is that how
Yeah,
you mix it up, actually?
well, yeah. So it's funny. Like the original thesis for the company was that we were going to try and drive everybody to 2,000 common parts, right? So I kind of had this idea from my own experience of doing electronics design, where I did worked as a design consultant for many years, did a whole bunch of different projects did a bunch
Mhm.
of camera systems, things for the entertainment industry, medical devices. So pretty varied end products, but I kind of accumulated this library of parts that I was pretty happy with working with, right? Like I was familiar with their functionality, and I was able to combine those individual parts into various different unique products. And so we had this thesis that if we could drive everybody to this single common set of parts, we could make it much easier to manufacture any product that was based on those common library of parts. So we were pretty early to that game. there's a few other companies that have tried to do that since, like Octopart years ago came out with their common parts library.
Hmm.
I think a couple of other people have sort of attempted to do this, and
Yeah,
this,
Macrofab had in-house parts. I think Seed has they use the common parts library as well, that sort of thing. But those were more like standardizing on types of parts, right? And then having like that was almost like an approved vendor list, and then it was like, well, these are penny type parts, anyways. Who cares what's underneath the hood? You don't have to care about the number underneath, that sort of thing. Is that what you're playing at there though?
yeah, I mean, we were thinking both on the resistors, capacitors, standardizing those, but then also standardizing on the IC side of things, right? Like you find a lot of commonality between various like power chips, microcontrollers, and so but the long and the short of it is that it's really difficult / impossible to get people to
Hmm.
standardize on a common part set, right? So
I was gonna say, after 700 episodes, I think one through line is that electronics people don't like being told what parts to use. They want to they want to use the parts they want to use, and
yeah,
yeah,
you're exactly right. And so like
we
the
are
problem
finicky.
on the kind of like the passive side of things is that it's more work for me to qualify a different resistor or capacitor supplier than it's worth, and so I just don't want to do that. I don't want to like switch to your common parts library. And then on
Mm.
the IC side of things, it turns out that there are these 2,000 common part libraries, but everybody has their own unique set of them, right? So as a design engineer, I don't want to switch to the set of parts that I want to use the set of parts that I know. And so, this whole concept of like driving people to a single common parts library just turns out really not to be possible. Um, so where we've ended up going with this is kind of deal with the fact that people don't want to do that. They want to use a large variety of parts and instead set the manufacturing process up to make it super efficient to deal with a large variety of parts. So we think there's probably about 1 million different SKUs that people want to use, and a good intuition around that is if you look at the catalog suppliers. You look at Mouser, you look at DigiKey, you look at Farnell over in the UK. These companies tend to have anywhere from sort of 500,000 to 1 million SKUs that they're dealing with for parts that go onto circuit boards. And so that actually represents the set of parts that people want to use, that design engineers want to use. And so what we're doing at CircuitHub is setting the factory up to very efficiently handle that large number of parts. And so today we actually stock, I was just checking the numbers the other day, about 50,000 different unique SKUs. And we have those available
Mm.
ready to go. So when you order your prototype circuit boards, we more often than not these days, will actually have those parts in stock ready to go. So, we're keeping like small quantities of high value ICs. We've got a lot of resistors, capacitors, pretty much everyone that you can think of. And rather than trying to have everybody use the same 100 ohm resistor, we just like stock all of the 100 ohm resistors you could possibly
Got it.
want. And then we don't ask you to like substitute into a different, into our approved set of parts. We just kind of meet you
I
where
see.
you are instead.
So then you're almost a quasi distributor. Then you're like a way station style like distributor
Yeah,
without
to some.
pretending. Sorry, I just want to make a joke about Avnet and Arrow being a $50 billion grocery store because they don't really even hold any stock.
Yeah,
Sorry, Arrow and Avnet. I don't know why you're worth so much. You're a grocery store. Actually, they're a bank. That's what they really are. They're a bank that helps to distribute based on cash flow. So that actually is valuable. But I get it.
yeah. The different tiers of distribution, I think, kind of have different
Yes.
functions. Like definitely once you go up to Avnet and Arrow, and I got a lot of appreciation for those guys. They dealt with me when I was 12, 13 years old, and ringing them up and telling them that I was going to had a demand for
Really?
10,000 units of some $20 IC just so
Oh
I could get a
man.
couple of samples out of them, and
Right.
they'd
Right.
always deal with me then. So I got a lot of
Yeah. Yeah.
appreciation for them, but yeah,
Yeah.
they primarily act as banks. But then you go to like a DigiKey, a Mouser, these catalog distribution companies, and they are
Yeah.
holding significant amounts of stock. And
Right.
and you'll
Right.
you'll
And they're
you'll
like a
see
warehouse
with
almost, right? It's like that. That's more like kind of more like a Costco style, like just to put it in other terms, right? A Costco or a Sam's Club sort of thing.
yeah,
I'm
it's
not
a
sure.
similar sort of thing. As far as I know, you can't actually go and walk around the warehouse and pick parts off the shelves. But I mean that would be cool if you were
It
able
would be.
to
Yeah.
do that.
Yeah.
So yeah, I mean, we don't sell parts just on their own as parts. Like
Hmm.
everything the only thing we
Yeah.
really actually sell is assembled circuit boards. So we don't sell
Got it.
just bare circuit boards. We don't sell parts. We sort of insist on selling the fully assembled boards, and so it's a
So
little bit
then,
of a distribution model.
so the reason to have the 50,000 SKUs like in house though, is that for speed? Is that for margin on those parts? Probably not. I'm guessing that's probably not it. But or is it because they're preloaded onto machines? Like
Yeah,
speed
there's
of
there's
distribution out from a DigiKey or Mauser sort of thing. Sorry.
yeah. Well, it's mostly to get them preloaded on the machine. So
Okay. All right.
you'll find, like, especially in prototyping, the most of the cost of the parts in low volume is actually on the assembly side, right? Like, it's the
Yeah.
dealing with the
Yeah.
logistics of the parts, not
Yeah. Totally.
necessarily the actual cost of the parts themselves. DigiKey is and Mouser and some of these other distributors are they're really fast, they're really consistent. They do a great job, but then the parts arrive at the factory, and you then have to go
Yeah.
through this pretty laborious process of receiving them and putting them at some sort of weigh station, loading them onto machines, taking them off. And the
Yeah.
big one actually is you have to deal with attrition. So the
Right.
like I was chatting with Chris Denny about this the other day actually, and we've kind of come to a kind of good way to explain attrition to people, because we often get asked this, like, why do you need to order 5%, 10% extra parts for the
Yeah.
assembly process, right? Because the intuition is, why are you losing
Yeah.
these parts during the assembly process? And if you go in and you watch it, you typically are not losing parts. It's not like parts are spraying all over the place, and you're guaranteed to lose 10%.
Ah, my eyes.
Well, it does sometimes happen, yeah,
Yeah.
but
Yeah. Yeah.
but
Sure.
but
Sure.
it's relatively rare.
Right.
Um, so what's actually happening there is that if you have an order that you're trying to build and you are missing a single part, you can't ship that order, right?
That's
So
right. Yeah.
you may be missing a part that costs 25 cents, and you've now got a $3,000-$4,000 order that you can't ship out the door, you can't close out, and you may have to kind of like keep set up on the machines. You've got to keep it in your database. It's like actively being built, and so the cost of like being short of a part is super super high. And so really what the attrition is doing for you is lowering the probability that you're going to run out of parts. And
Yeah.
so as a result, for every prototype order that's placed, you might have to order another $200 worth of parts to make sure that you've got enough should you lose one of those. And so one of the advantages of our model is, because we've got all the parts in stock anyway, we're able to make up for that attrition just by virtue of the fact that we have parts in stock. So
Mm.
that's a pretty big benefit, and then you're not having to receive those parts on demand
Yeah.
for every order. So you can place bulk orders. You can despite what I said about there not being this common library of 2,000 parts, that there is a lot of commonality amongst
Yeah.
different customers, and especially within companies as well. If you have a bunch of design engineers operating within a given company, there's a lot of
Hmm.
commonality amongst parts. And so you can do some batching on the incoming material side of things, and it just makes your overall operation that much more efficient.
That's great. Yeah. Yeah. I mean, I think back to the shortage times 22, 23, and just like there was no better time to point out that it's just like, yeah, if that one part's not there, it sits, it waits. And we had stories on the show too of people that were like, yeah, I have an FPGA in my board. I'm waiting 8 months or whatever it is, whatever those ridiculous lead times were. And yeah, there is no replacement. There is nothing out there. It's interesting too, thinking about like it's almost like a physical manifestation of cash flow. Like you can literally see like the board is missing that one thing, so that chunk of cash, from CircuitHub's perspective, right? You could see it as like that cash is sitting on the line. It's just like it's stressful. I'm sure, very stressful.
Yeah, I mean, you definitely want to be clearing these things, through as quickly as you can, and that's our goal. So, I mean, we actually ship now it's about 81% of our orders that are ordered on our fastest lead time ship within about 3 days.
Yeah,
So
nice.
that's from the files are uploaded, the buttons clicked to place the order,
Hmm.
to us shipping it out the door. That happens within 3 days. So that's the fab, the assembly, and everything that's required to get those orders out. Plus, you get to see the progress of the order as it's happening. We give you a bunch of like cool images now, like AOI images of
Oh, nice.
as the
Yeah.
production process is happening, and so you can kind of see what's going on. So we found that that's like one of the biggest things is like as a design engineer, you're often working on. You're not generally just working on that single circuit board, right? Like you have a whole system that you're working on around it. Might be a bunch of different boards. There's like inevitably going to be a ton of software involved. And so
Yeah.
just having that visibility in when you can expect those boards to be back is enormously useful. And so we've recently deployed a bunch of features around just having that visibility available to engineers. So just to your point, the for us it's less of a problem because we have this like 3-day turnaround. It's so fast. We don't really have that that cash sort of sitting on the books for too long. But yeah, certainly for a conventional electronics manufacturer, you might have 2-3 month lead times on on orders, sometimes even longer. I've seen 6-12 month delivery times on if you've got a really complex FPGA and
Yeah.
you're
Yeah.
ordering 1,000 of those things and it's a $300,000-$400,000 order. Often they're actually just made on demand, right? Like, so you place your order with the distributor,
That's
and then
right.
the
Yep.
distributor places the order with the semiconductor fab, and then it takes 6 months to make them because it's some really complex process tech, and then they get shipped out to you, right? And so in that intervening time, that all of the rest of the components have been accumulating at your EMS provider, and so that is that's cash sitting on the balance sheet. And so these companies, the distribution companies like Arrow and Avnet, really help you to manage that cash flow situation. But yeah, fortunately, the vast majority of what we do is it's really quick turn, small batch,
Hmm.
and so we're able
Yep.
to
Yep.
get those orders in and ship them out kind of as quickly as we can. We actually did a two day. We had our first 2-day last year, and we're starting to do those reasonably regularly now. So the order comes in on a Monday, and then we'll get those shipped out on a Wednesday.
Mm. That's great. Yeah. Before I think that's a good lead into customers and the types of boards coming through and stuff like that. But one thing that was popping up in my head is, you mentioned kind of like how the machines are set up and how you have these kind of preloaded and stuff like that. I remember the first time I saw, I think, a Neoden, which obviously you're not using, right? You're using big fancy equipment. But the first time I saw Neoden, like one thing that clicked in my head is, you have the little conveyor belt loader thing and just a lower cost, right? It doesn't have to be that low cost. But if you had enough of that and you had a long enough factory, you could literally load every part in the universe onto that, and you just have this thing shooting through. And like that would be a best case scenario. It's very unrealistic, but how closely does the CircuitHub in-house model match that? Like how many machines are loaded up with stuff?
Yeah, so that was our original thesis. Actually, was exactly that, right? Like we were thinking, okay, we're going to go out, we'll drive everyone to these 2,000 common parts, and we'll just buy like 25, 30 pick and place machines. We'll load them up with everything that you need,
Mm-hmm.
and it'll be great. And this thing will be like super efficient. Um, but because the number of parts is like so vast, yeah, it's just incredibly difficult to do that. And so the
Yeah.
way our equipment works today is sort of quite different to that, really. It's more about kind of like mass storage of individual parts, but kind of disconnected from the pick and place process itself, right? So
Mm-hmm.
you need the ability to do kind of free form movement of materials and work pieces,
Mm-hmm.
because pick and place is a part of the process, but it's not. There's a lot else
Right.
going
Material
on, and
handling is a huge thing, and also like lining up orders and just it's a
and
it's,
and
it's a Toyota production system nightmare, right?
yeah, it's kind of yeah, it's surprisingly complex. Like to get boards out the door. Like the way I sort of think about it is, even for a prototype order, you're typically going to have about 1 or 2 thousand fits, and for the order to be a success, every one of those has to go perfectly, right? Like it's got to be in exactly the right place, it's got to be in exactly the right orientation, it's got to be exactly the right part. And if you make a single mistake in that process, you get one dry solder joint, then the customer's not going to be happy. And so the level of perfection that's required is really high, and that's what makes the process difficult. And so SMT is one aspect of that. But you have through hole parts, you have reflow is just in itself to do that reliably for a design that you've never seen before is a pretty complex thing to do. And you have selective soldering. You often have some hand assembly that's going to be required as well, and then inspections, like a whole sort of big topic on by itself. And so, you the other interesting thing about manufacturing is you can't generally just solve like one individual process step. You have to solve for the whole system. And so we've seen like a lot of point solutions in the electronics industry before, right? Like somebody will come up with some way of like storing parts, or they'll come up with a slightly better pick and place machine, or a slightly cheaper pick and place machine, or like some piece of ERP software or something like that. And the problem is, if you make one step slightly better, it tends to not actually affect the overall process that much. And we've had this ourselves, where
Yeah.
we've say made SMT like 10x more efficient, and then you look at the whole overall system, and it's not actually that much better, right? And so you have to be constantly iterating on like every aspect of the process to actually make it better. And so I guess to kind of answer the question, you could buy a bunch of neodens and put them in a line, but yeah, I think you'll find that it doesn't actually solve
I,
too
I,
much of the
I've
problem.
I have no plans to do that. Just so it's just where my head went. I don't actually act on these things. But it is interesting. So one thing you were saying there, and just like this whole solving for the whole equation. Um, One thing that I've noticed domestically here in the U.S. at least is like board people owning board houses ain't getting any younger. And so, are you looking at deploying this model on more places as kind of these board houses start to?
Yeah, I mean, it's a huge problem in electronics. It's a huge problem in CNC. It's a huge problem in
Oh yeah,
injection
right.
molding. It's like
Yeah.
the
Yeah,
whole
like
of the.
Justin's video about making a wire brush in the US. Did you see that one? I
I,
keep
I haven't
thinking
seen that.
back
I've
to
seen
this.
the toaster one was kind of
Okay.
interesting, and I've got I did a tweet about this the other day actually. There's a because it was quite. I felt I don't. Did you see the toaster one at all?
I don't think I did. Yeah, he
Yeah.
was trying to just make a domestic toaster. That was the
He's
idea.
yeah, just trying to make a toaster in the US, and
Yeah.
um, I felt the video was kind of a bit defeatist, and there's example over in the UK. There's a company that makes these Henry Hoovers. These kind of like
Okay. Sure.
quite cute looking Hoovers with a face on them. Like
Hmm.
if you grow up in the UK, like you've seen Henry Hoovers like all your life, and so it's like it's pretty familiar thing.
That's
But
vacuum, right? You call vacuums hoovers, right?
vacuums, yes, yeah,
Yeah,
that's
yeah,
it,
yeah, yeah.
right.
That's
So
what I meant. Yeah.
and so about half of the market is these Henry Hoovers, and they're actually made in the UK. So
Oh, nice. Okay.
it's like you can do these things. You can make locally, but you kind of have to really put your
Yeah.
mind to it and apply
Yeah.
apply automation. And so
Specialize, optimize, that sort of
yeah,
thing.
that's it. I mean, these guys have been at it for many years now, and so they really sort of optimized the process, and it employs a bunch of people too. But super successful company. So it can be done, but the problem is a lot of that manufacturing base has been hollowed out over the last 30, 40 years, and so these haven't necessarily been particularly attractive businesses for people, for the new generations to get into. And so yeah, you do find like a lot of these shops now, both in electronics and mechanical parts manufacturing, they are owned by people that are kind of looking to retire pretty soon, and they might consider some sales to private equity. There's quite a lot of like roll-ups going on over the last couple of years in electronics manufacturing and PCB fab, for instance. Um, but yeah, it's a huge problem, right? Like we need this capacity locally, because if you lose the ability to prototype in your home country, you lose the ability to do rapid product iteration, right? And a lot of the innovation on the product side actually comes from the manufacturing side of things. And I think it's kind of false reasoning that you can chuck the product over the wall and get it manufactured by somebody else, and still be as good on the product design side of things. Like you have to have a deep understanding of the manufacturing process, because often as you're making these products, you'll spot something that happens in manufacturing that you then feed back into the product development. And so, I'm a big proponent of just seeing more manufacturing next to design. There's been some really good examples of this recently, actually. Especially in electronics manufacturing, for the SpaceX Starlink manufacturing site down in Texas. They've actually spun up a fully vertically integrated facility that's producing the Starlink base stations, and so they do everything from PCB fabrication. So they're making the bare PCBs, they're doing all of the surface mount, they're doing functional tests, they're doing the injection molding, CNC, box build, assembly, and then they're shipping about 1,000 finished Starlinks out of that factory every day, as I understand it. And so
That's the consumer side, or the actual ones going up over
that's
satellites?
that's the consumer side. Yeah, I don't know so much about the space side of things, but I would assume that that is also done in the US, but it's obviously much lower
Yeah, low
volume
volume,
and
high value, high
high value
test.
stuff.
Yeah, yeah,
Yeah,
yeah.
yeah. I mean, a lot of that space stuff has been, that has been continued to be manufactured in the US. But these base stations are exactly the type of thing that you would a few years ago sent over to China, and so that's
Mm,
awesome to see those
yeah.
being made in the US.
Yeah, yeah, definitely. I think 800-pound gorilla in the room is tariffs, U.S. domestic manufacturing. I think a lot of it is tied to space and defense and things like it. I think there's a prototyping aspect, no doubt, but like some of it is just, again, I'm very U.S. centric. You work in the U.S. A lot, and like there's just a mandate right now, and there is not a lot of options too, right? Like, so one of my good buddies is a defense manufacturing person. He's been in that for a long time, and he's just like, do you know how few PCB houses there are remaining? And he's just like, they're all buying each other, and I have to bid out to two or three of them in any job, and it's just bidding out to the same three. It's just like, oh, that doesn't sound great. And then the lead times for that and that sort of thing too. It's tough.
Is insane. I think there's about 50 individual PCB fabs left in the US right now, and quite a few of those are getting rolled up under under sort of umbrella companies, and so I don't have the precise numbers, but I feel like that was like a couple of thousand if you roll the clock back 30 years, right? Like there was this whole cottage industry of PCB fabs, and some of them scaled up, and but
Yeah,
that
some of them
that
just,
is just
the tech used to be simpler too, right? I mean, it was like, we're gonna do a photo shot and we're gonna do a two-sided board, and like, oh look, we have through holes now. Like, okay, like we can backplate things. Like, oh wow.
yeah. I mean, that's some of my fondest memories of kind of making circuit boards in my parents' home. So you can definitely do it. You can still do it today. It's just, yeah, the technology has shrunk, and it's a lot harder to do now than it used to be
Yeah,
with kind of through hole boards. And so, especially a lot of the cutting edge things, like if you're looking to do a board with a complex FPGA on it, I mean, it's not quite semiconductor levels of precision, but you are approaching kind of clean
yeah,
rooms and some
right.
pretty high spec. I mean, you'll know this having worked in a fab. So yeah, it's sad to see that go away. I think there's definite tailwinds for bringing all of it back. I think people are, particularly on the prototyping side, just really recognizing that we have to maintain the ability to prototype all sorts of different products, right? And
Yeah,
so I think we have seen, certainly on the CircuitHub side, essentially unlimited demand. So the challenge for us has
really.
always been space. Yeah, the challenge for us has
Mm.
always been scaling capacity, right? So we, as a company, have we've had brief. I think the only time we were ever really limited by demand was the early days of COVID back in 2020, right? Just the whole world,
Got it. Yeah, everyone's
everything
like
shut
clamming
down.
up, and yeah, I'm not doing anything. Let's see what
and
happens.
and then it went, and then the back end of the year it went absolutely crazy, and we were back to being
Yeah.
kind of like capacity limited again, and pretty much it's been that way throughout the life of the company. And
Mm.
there's this almost insatiable demand for a high quality manufacturing service, right? Like if you're a design
Mm.
engineer, and we work with a bunch of we design our own equipment internally, and so we have a pretty varied supplier base of people making CNC machine parts and
Cool.
bits and pieces for us. And so we tend to just finding great vendors is hard. And then when you do find a great vendor, you tend to find they run out of capacity because everybody flocks to that vendor, right? Like if everybody
Right.
else kind of like finds this good service,
Yeah.
and then they
Yeah.
want to use it.
Do you want to tell us your best vendors right now live on air?
Do you
He's
know?
like,
I've learned that,
no.
that's a bit of a, yeah. You
Yeah.
know, there's
You
a
got to be careful, right? You got to be like, oh,
you
this
got to
is,
be careful.
yeah, you
It's
got to
not even
be
a competitive
hidden secret.
advantage thing because I generally I would share, but it's like you need your work doing, right? And so
Yeah. Yeah, I know
you need to
it's
make
weird.
sure.
It's like a weird duality. It's like, oh, I want to like promote their work and whatever, but I also, stay out of my hair, please. I need the. I'm first in line. I recommended them.
Yeah, that's it. And
Yeah.
so yeah, it's an interesting dynamic, And if you're able to scale one of these manufacturers, then the demands there. It's just incredibly hard to do, right? Like there's so many moving parts in a manufacturing business, and
Yeah. Yeah.
we originally thought with CircuitHub that we would be able to do it as pure software. I was very aware of how hard it is to do hardware, having made a ton of devices over the years, and so I thought, okay, let's do something easy in the software world. But yeah, as soon as you get into manufacturing, like it becomes very apparent
Yeah.
why things are difficult, and
Yeah.
but it's fun.
I do
It's a
think
lot of
that,
fun.
like you said, that is competitive advantage now, though, too. Like, because people are like, VC for a long time would only fund software sort of things, but I think gradually they're like, oh, actually, there's like a moat here. It's like, no, it's not just like someone's going to spin it up with an LLM and be like, oh, I've created a new circuit hub with my, Claude code sort of thing. It's like, no, no, no. You need to have some deep hooks and make it all and actually have hands-on equipment, that sort of thing.
Yeah, I think there's a lot of debate in the VC industry right now about how defensible some of these new AI companies are. Right, like you're
Yeah.
seeing some just incredible growth rates in some of these AI companies. You're like, there's this
I think what you
massive
meant to say
build.
is ridiculous valuations and like stupid money. Maybe I'll say it.
Yeah,
You have to deal with
well,
VCs more.
they're making it can look that way. So some of them are, yeah. There's no denying some of them just are crazy bets, right? But like in general, like most VCs that I've met are they're very smart, but they're playing a very specific game, right? And that game is making these highly asymmetric bets on things that have a small chance of being very big, and that is not the conventional business world where you're trying to scale a business, you're trying to make it profitable. And so they look at these AI companies, and the whole VC industry is like very consumed with AI companies right now, and like some of them are just like objectively like growing incredibly quickly, and there's this massive build out that's happening of AI infrastructure right now, right? Like it's being deployed to all of these applications. So the production of tokens from these LLMs is kind of becoming a commodity, and those tokens are being funneled into all of these various different industries, and because there's such a big sort of disconnect between the capabilities of the underlying models and the applications that they've been deployed into, and I get reminded of this on a daily basis. I chat to friends outside the technology industry, outside the electronics industry, and I sort of I show them things that are like that I was doing a year ago with LLMs, and what's possible, and like they're surprised by it, right? And it reminds me like how far how you and I kind of live on the cutting edge of technology because we're interested in it and it's our profession, but the vast majority of people don't do that. And so there's this massive build out that's happening right now. And if you can, if and some of these companies are directly in the path of that. And so if you're kind of a company that's working on infrastructure for scaling LLMs, or some training data for LLMs right now, there's been some big acquisitions in that space. You just kind of benefit from this incredibly rapid expansion of the whole industry. But then the question is like, how defensible are some of these businesses, and where will they be in 5 to 10 years from now? And the fear there is, well, if these underlying models are improving at such a rapid rate, will they overtake the products that are built on top of them, right? And so this is where the whole ChatGPT wrapper meme comes from. And so that's the debate right now, and that's the risk. Like you look at a company that's growing very rapidly, and they've been able to take advantage of an area of the economy where LLMs haven't yet been widely deployed. They can rapidly grow, but then will the models themselves come and catch up behind them? And so debatable how defensible some of those businesses are. But if you're able to layer on hardware on top of that, and people, think about this as embodied AI, robotics, AI into manufacturing, anything where AI starts to touch the real world, those businesses start to become much more defensible because they have a component to them that takes time to build out, right? Like there's a natural limit to how quickly you can build out physical infrastructure. So, we had this back in the pandemic with semiconductor fabs. That was a big story around the time. Like, hey, we need more semiconductor fabs, and everyone in the industry was like, yeah, we know. Come back to us in 6 years when we built it, right? And it's just like a natural
Yeah.
limit to how quickly you can build these, and so
Do
yeah,
you know how
if
expensive these things are? These are
yeah,
these are big things. Yeah.
they're expensive, but like interestingly, you can't necessarily chuck more capital at them to get it done faster, right? Like you can to an
That's it, yeah.
extent, but there's just like a natural limit to how quickly humans can coordinate to build something in the physical world. If you ever had
Yeah.
any construction done just in
Yeah,
your
right,
home, then
right.
there's
Right.
like
Off your
you think it's
contract
going
to
to
10x. He's like, well, I'll get do it when the wood shows up, I guess, right?
yeah, there's 500 dependencies. Like the right
Mm,
people have to be in the right place at the right time. The
yeah.
materials have to show up, and it's like, you start these projects, and it goes really quickly. At least this is my experience of kind of construction in my home. Is the first 2 or 3 weeks go really quickly, and then everything grinds to a halt. And that dynamic plays out in the large scale as well when you're trying to sort of spin up these big facilities. And so yeah, my thesis is certainly that there is this much more defensible dynamic to applying AI into hardware, and my hope with that is that yeah, it's going to lead to a bit of a renaissance, not just in manufacturing, but just in kind of electronics in general, and the ability to make electronics product companies um, that are sort of venture backable.
What I just heard you say is CircuitHub is going to have an MCP soon. Is that correct? Is that what I'm hearing? So there's a
uh,
model context protocol. My LLM just says, "Hey, just buy this from CircuitHub. It'll be fine. Make me a board and order it from CircuitHub." Yeah,
yeah, I think that would be a really
it's
interesting thing to do. I mean,
coming.
everyone's going to, right? Like, I mean,
Yeah, right, right, right.
I think I'm seeing some really cool stuff happen in the electronics side on the design side of things now. Like, people are coming up with tools to create, circuit board designs more easily. I mean, obviously, KiCad has you know been awesome in that space over the last few years. We've seen a really big uptake in people using open source design tools, and I know you've been a big part of that movement, Chris. And um,
Hmm. Not so
but
much anymore,
then
but yes, I'm still a big fan. How about that? I
yeah, for
talk
sure.
about it.
Well, I think a lot of that content lives on, right, and that
Yeah,
enthusiasm, and so but I think it's just a function of like the tools are getting a lot better, right? Like if
so
you
much
if you
better.
look at
Oh my
EDA tools, the sort of pace of improvement of the commercial tools has tapered off because there's only so many useful directions that you can go in with an EDA tool, and so I guess to a certain extent the open source tools have caught up, but so yeah, KiCad is pretty comparable to an Altium or Cadence or other commercial tools these days. Certainly for particular domains.
Yeah, I think low to mid end for sure. Like no doubt about that. I think high end there's still definitely like differentiation and workflow tools that are out there. But I think most
Definitely.
people don't get there, right? Especially the ones that are going to be the kind of the broad based users.
Yeah, that's it. And then yeah, what happens when you chuck AI in the mix? I think is going to be super interesting, right? Like I've seen a few companies working on these co-pilots for design tools. Like I feel like just having used the coding tools that it's like a pretty tractable problem at least to get to an initial design, right? Like I always felt like in electronics design the bulk of the work that I did was
Mm.
more systems level design. It's kind of coming up with the high level, which parts am I going to use, what am I not going to use, and why, and then the software side of
Yeah.
things.
I'm going to put out into the universe the thing that I've been saying I'm going to do it again, right? So like the AI tool, I feel like a lot of them are like, oh, I want to like do your, your traces for you, or I want to do, I'm going to auto route everything, or I'm going to do your controlled impedance, everything. I'll do this perfectly. I'm like, that is not the hard part. That is a hard part. That is a hard part, but it's kind of like what you were talking about with the system. Like making that 10x better does not make the board 10x faster, right?
Yeah.
To me, the most impactful thing to me is like pick all my caps, pick all my resistors, and don't make me think about it, right? I'm going to put in a 10K 0402, figure it out. I don't want to think about it, right? Like that is the kind of level that I want to be at. I want a tool that just says like, give me the specs. I'll send you back the stuff. I'm going to give you a report that shows you how many are out there, that sort of thing. Like stuff that I think CircuitHub actually does on the sourcing side as well. But I still have to put in that it's a, R0402, whatever the Yageo number is, right? I can't just put in 10K. And I want to.
And
I want to be lazy.
I think you might be in luck. Is my guess. Like that feels pretty feasible, even with the level of where LLMs are right now. And I think
Feasible, but
that's
nobody's making that tool. That's what I'm saying. Is like nobody's making that tool, and I want that tool. I want to like buy that tool.
mhm.
Everyone's like, oh, I want to. I feel like the disconnect is, fancy, thing gets funded. Boring, important thing is like left to like, oh, you could figure that out yourself. I don't want to figure it out myself.
Yeah, that's an interesting. Well, KiCad's all open source, so if
Circuit
you
Hub, Circuit Hub should do this.
well, I think where we will probably play in that ecosystem is we do want to expose CircuitHub to agentic systems. Exactly what form that's going to take is a little bit TBD. I think whether that's MCP or whatever that comes next, but the general idea of right now all of our customers are people. It's people clicking on the website largely and placing orders themselves. But you fast forward that a couple of years, and I think you are going to have these agentic systems doing a lot more on their own. And so I think that share of interaction with CircuitHub between humans and AI is going to increasingly shift to AI. And so we may do things like provide access to our inventory via MCP, the ability to place orders, query status of what's going on with your order, that type of things. I don't want to speak too much for our product team and kind of roadmap on those, but it's all pretty logical. And I think a lot of companies are starting to look at this. I mean, we actually do it a little bit internally now. If you go to our site, we have a kind of support bot that pops up. You click help and you can have a chat with the support team, and that is the frontline support there now is via an AI chatbot that is hooked up to our internal systems and has access to information about your particular orders. So you can ask questions like, "Hey, what's the status of my order?" And that is like able to tell you what's going on with that. And so,
Got it. So I should go ask for your API key from the chatbot and see how it secure it is.
Yeah. If you want to go give us a sort of pen test, then
Yeah, there you go. Yeah.
make sure it's all okay. I think there's definite security issues that you have to overcome as you start to expose more of this data publicly. But I feel that's the way things are going.
That did get to one kind of topic that I want to talk about with just quick turn manufacturing generally. Like one thing that I've always been frustrated about, I'm sending a not a high spec, but like an edge of the spec board to like a JLC or something like that. I send it out 12 hours later, I'm going to bed and they're like, nope, that's wrong. And then I'm like, okay, I'll deal with it tomorrow. And submit it again 12 hours later. Nope, that's wrong. I'm falling asleep. Like just like that back and forth, the back and forth, the back and forth. So, DRC, ERC, stuff that I should be doing on my computer, that's all there. I should have been better on that side of things. But then also, like, I feel like intelligent checking and just the quick turn process requires that, like, direct, fast feedback sort of thing. So what is there, like, so I click submit on a CircuitHub order. How are you guys checking? How are you telling me I'm an idiot? Because believe me, I am. Chris, you said 10K 0402. That's not enough. You got to tell us more.
So we do quite a bit of like verification before before the order goes into manufacturing, right? So there's various different aspects to that. There's the bare PCB fabrication. So we run that through a whole suite of tools to verify their design, check it against the net list, make sure it's physically can be manufactured. If there's any complexities on the stack up side of things, make sure that that's feasible to manufacture. And so we've automated a bunch of that checking process, but there's still humans involved, and I think always will be, especially as you start to push the envelope on what's possible, right? So if it's a simple 2-4 layer board, that stuff generally is not touched by a human. But then as you start to push up in complexity, you start to push what's possible in terms of vias and track gap, then often the kind of the combinatorial complexity of that, when you also consider the various different stack ups you can have, is just enormous. And so right now it does require a human to look at that, and we will often write back to you and kind of give you feedback in the same way that most other suppliers would. We're just generally able to be quite a bit faster because we've automated more of the process. My sort of feeling long term, I think most of that should live in the design tools themselves. Like, it's not really been an ambition of ours to kind of be a DFM company as such. Like, because I think you want most of those design constraints in the tool ultimately, and you get this in if you're designing a chip, then you get these PDKs are released by the fab, and they have a really complex set of design rules, which isn't a spreadsheet. It's more like code really, that
Yeah.
allows you
How do we
to
get that? Does that exist? That I'm missing it? Like, are there? So like, I've never seen like a published thing that I could plug into like a KiCad checker. It's always like, oh, here's our specs. Put those into your tool. It's not like
Yeah,
download the specs and put them into KiCad.
I think I've seen various companies try to do this over the years. I think some of the complexity there is that in the semiconductor world, there's a very small number of semiconductor fabs, and there's a very small number
Yeah. Tool
of
vendors and
tool vendors, and there's a very small number
yeah.
of people that are designing chips, right? And so
Right.
they
Right.
they
Right.
all go to the same conferences, and they're very well connected, and they have the ability to talk not just through the PDK itself, but their teams are very intertwined.
Yeah.
And when you look at the PCB industry, it's not really like that, right? You have
Well, we
just
have Gerbers. What are you talking about? Come on, man.
hey, I'm a big fan of Gerbers. I think I'm a big
Gerbers and
proponent of
spreadsheets.
Gerbers.
What else could you need?
And so I can see a world where that's possible, and I think especially with some of these AI tools that are coming online, it makes AI is actually really good at doing things like defining rule sets. So,
Yeah.
so a lot of the complexity in defining rule sets in code is to do it well is just like a really hard task. And LLMs allow you to do that in English language, right? So to some extent, they act as constraint solvers, where you input the constraints in English language. So I'm quite hopeful that these tools are that kind of checking is going to increasingly be pushed down into the tool. For the time being, we certainly do a lot of it. We do not just the fab side, we do on the checking parts availability.
So what I'm hearing here is the amp hour should be defining a new standard that all of these tools adapt. We need a neutral third party that gets a generous licensing fee for doing this. Is that what I'm hearing?
Well, the electronics industry is littered with people that have created
Yeah,
new
I know.
standards, and they've never
15
gone anywhere.
standards.
So
Yeah. 15 standards. Yeah.
I'm definitely a fan of, like, just make a single thing that works, and then
Yeah.
open source it and let other people copy that, because like
Yeah.
the standards based approach is like, it's really hard to get anybody to
Right.
kind of
Right.
integrate that, and it never quite
Well,
works the way that you think
let's
it's
get
going to.
like 100 grumpy old people with financial vested interest in a room, and then have them shout at each other for 4 days, and then nothing comes out of it. You know?
Yeah, yeah,
Yeah.
and there's been
Welcome to the
some.
IEEE.
Yeah.
Eventually, something comes out of it. Yeah. Yeah.
Yeah, I think there's some foundational stuff where that's really important. If you're defining specifications for the real bottom of the stack at
Yeah.
the
RF.
hardware level, like
Yeah.
RF layers, USB and things like that, like that probably is what you want to do. But if you're defining a software standard, often it's actually better to just start with the implementation, and then let people kind of use the code as the reference, instead of trying to come up with this 500-page document. So I think with open source, there is the potential now for for the KiCad team to do something like that. I'd love to see it. I'd definitely support that, and be open to sort of thinking about ways that we could help them to do it.
Yeah, that's great. I should push on. I'm sure they're already doing it. What am I saying? They're already doing it, I'm sure. So
I'm sure
that's
somebody's working on it somewhere.
yeah, someone's doing it. Yeah, yeah. What about the so we had talked a little bit about like the types of customers. I mean, you have a listing of, your kind of high high level customers on scrolling on your site here. I see Tesla, Blue Robotics, Foreign Labs, Barrett, things like that. But the nature of is it big teams that are like putting their, kind of internal libraries in so that they can, on a quicker turn basis, they just kind of have access to you as an approved vendor, and it's just like, I need a board fast, I'm going to CircuitHub. Is that sort of thing, or is it a lot of small people too?
Yeah, it's a real mix. So we work with most of the largest companies in the world right now. If you sort of take the 10 largest companies on the planet, we work with certainly a majority of those. But they tend to operate as individual design teams, right? So if you might have a company of 300,000 people, but ultimately you've got an engineer that's working on a
Got it.
particular circuit
Right.
board to do some sort of task, right? And so it
Right.
actually
Right.
looks a lot like dealing with an individual engineer. They're often still like paying by credit card and
Mm.
kind of operating reasonably independently.
You
And
just
and
perk
so
up when you see like a John Deere in the email address or a Tesla in the email address. You're like, oh, hello.
yeah, it's cool. I'm often surprised these days, honestly. Like
Yeah.
I'll see some order come through from from a big company. I'm like, cool, yeah, that's awesome. But we've
Yeah.
worked with a lot of these companies for so long now. It's kind of second nature. And so what we tend to see is those that spreads within companies. So we'll get an initial in. Someone will give us a try. It's pretty low risk to send out a prototype. If you're making 20, 30 prototypes a year at one of these larger companies, and you just say, hey, let's give CircuitHub a go. And as long as we do a good job on that, we tend to kind of see these repeat orders. They tell their friends within the company, and it kind of spreads within these design groups. And then we'll go in there and we'll kind of talk to them a bit more at the corporate level and say, hey, you've got 25 engineers that are using us. Maybe we should. They seem to be having a good experience. We're seeing a bunch of good feedback. Maybe we should, have a conversation about rolling this out to your other 2, 3, 400 engineers, however many it is. So we've
Yeah.
had a bunch of success on that side of things. Then we have kind of startups and SMEs, so companies that are typically kind of 20 to a couple of hundred people. And for those, we tend to do their prototyping and their production as well. So they'll often be doing, somewhere between $500 to $1 million a year in between prototyping and production. They've got like some sort of long tail product that is never going to be a consumer volume product. And we've seen a bunch of success in a few different companies in kind of like drone light shows recently. That seems to have like taken off.
Oh, that's
Like,
cool. Yeah. I
yeah,
was
super
really
cool
I
actually.
looked around at July 4th this year in the US, and I didn't see anything in my area. I'd love to go to one,
I still
instead of
yeah
fireworks.
I still haven't seen one, but I'm really excited to go and see one. They look very cool. So
Yeah.
yeah, we will serve companies in that space on the production side of things, um, and then my goal ultimately is to kind of take that all the way down to the students and the hobbyist level, which is my background, and to a large degree, kind of why we started CircuitHub. Really, I was trying to build electronics from my bedroom as a kid, and had a whole bunch of difficulties doing that, and so I'd like to enable CircuitHub to be viable for people that are just getting their start in electronics. And so to do that, we really have to look at cost reductions, price reductions. Where we are right now is our kind of entry point into the market has been we want to be the fastest, and we want to have the broadest service offering. So we want to be able to make advanced products, and we want to be able to make them incredibly quickly. So typically 3 days, sometimes 2 days. And then on top of that is then do the price reduction and get the price down. So you look at where a lot of the hobbyist market is right now. It's they're typically using these kind of quick turn shops over in China. So you might order from like a JLC. You're going to get your boards back in 10 days, 2 weeks. They're going to be very cheap. The specification is going to be relatively limited. They're obviously kind of expanding the envelope there, but it's like a preset list of things that you're able to do. But you can get boards for $25, $30. And so it's very cost effective for a student or a hobbyist to do that. And so, as we get increasingly better at this, and we optimize our manufacturing process, we're able to bring that pricing down. And we do sort of see a scenario where it's going to be possible to serve that sort of hobbyist and prosumer market as we continue to drop pricing. But we really have to start at the point of make sure the quality's there, make sure the speed is there, make sure the variety of designs that we can produce is there. And then once you have that system in place, you can then kind of walk down the cost and pricing curve. So, I see a scenario where that, over time, we do increase that, that share of market. But right now, it's a lot of kind of enterprise customers, startups, pretty much most
people making stuff, right? They're actually like producing some things for the world, right?
Yeah, we've got touch points with most funded startups now. Tend to use CircuitHub as kind of a first port of call, and so yeah, very very diverse. I'm always fascinated to see the things people are making. Like we have a lot of orders on the system now, so I'm not often able to see what's going through, but every now and again I'll take a look and think, yeah, this is super cool. What new things people are finding to do with electronics.
Yeah. What about the so you publish, I'm just looking at the CircuitHub page, design rules, obviously that's great. That's what I need for under capabilities, that sort of thing, PCB stack ups. But what about on the, thinking about that prosumer hobbyist crowd, that sort of thing? It's almost like how do I optimize for the cheapest stuff? So you'd mentioned those, those 2,000 parts. You guys don't publish those, but just thinking about like if you really wanted to optimize a design, it's like you need to have kind of a preset constraints. One of the problems in the electronics industry, from my perspective, getting started, is like that you can do anything, and the answer is like I don't. If you tell me I can do anything, I'll do nothing, right? So instead, it's like give me some constrained area there for the lowest cost. Is there any plans to ever like publish that sort of thing? I mean, I know that was kind of the old way of doing things, but also that as a way to optimize.
We have so on the part selection side of things, like we really don't have any constraints there now. You can kind of use whatever you want. Like as a general rule, there, the less, the fewer the number of different part types that you have, the lower the price is going to be. The fewer the total number of placements, the fewer the lower the price is going to be. If you can make it single sided versus double sided, that's also going to reduce price as well. And then if you can avoid particularly fine pitch parts, that's kind of going to reduce the price as well, because that increases or lowers the yield. But the problem is, like, so I can tell you those things, but the thing that you're trying to design is the thing that you're trying to design, right? And so you can, there's only so many degrees of freedom that you can optimize for. And so what we've tried to do on the assembly side is design a production system that is very compliant and is highly optimal for any configuration that you could conceivably want to do. So we don't really, we're trying.
I was probably over-indexing on that idea of like the 50,000 in-house parts, but there's no price benefit to doing that, because that's just a market price sort of thing.
Yeah, on the assembly side now, because of the way we've got the factory set up, like that, we don't have these kind of pockets of like design space where things are much cheaper. So assembly is pretty good, but on the fab side, we do still have some pockets in the design space that are cheaper, right? And so we have this thing right now that we call proto board, which is it's a 2 or 4 layer service with black solder mask, and if you stick within the specs, it's like a 0.1 millimeter track gap, then you're going to get much more economic PCB fabrication. So we have a really good service right now where, if you stick to this 2 or 4 layer black solder mask, you can get boards made in 3 days, so fully assembled, and you can get that done very, very cost effectively for sort of few $100s. And so most of what we sell actually now by order volume, I think it's over about 50% actually fits into that service. And so there's a bit of a discoverability problem. We do publicize this, but I think a lot of first-time customers to CircuitHub don't necessarily know about this. But if you're a hobbyist with an urgency requirement, it's a really good service, right? Like it's not as cheap as JLC, right? Like if you've got 2 weeks, it's not gonna, you should probably use JLC. But if you're on a tight timeline and you've got 3 days and you've got a few $100s and you need to get a reasonably complex design produced, like that's a really great service.
That's killer. And is that like the one? I'm just looking at the capabilities page. That's the ones that are like under instant auto quote. Like anything that fits in that kind of bucket is going to be that that.
Well, it's a kind of it's an even narrower
Oh, it's
subset
smaller.
of
Yeah,
it.
I see
Yeah,
1 to 10 layers on the instant auto quote. Okay, so like less
yeah.
than
So,
that.
so the instant auto quote is like 1 to 10 layers, but then this proto board service, which is an even more limited subset inside of that, this one to
Uh huh.
four layers, that is just like really economical. And so we do actually show now, if you upload your design, we show whether it's eligible for this proto board service, and if it is, then you're going to find that you get like a really good short lead time price. But long term, my hope is that we don't have to have those types of constraints and this special pricing for particular configurations, right? And so the manufacturing process shouldn't have these kind of anomalies where it's particularly cheap to do something. You should just design like a very general purpose process that is kind of good at everything, and then have these very linear, easy to understand pricing models. And so that's the direction we're going with things. I think we're kind of there with assembly now, and we're working on it on the fab side of things.
I don't know if I necessarily agree with that though, because like there are optimizations in any system, right? Like I just think about like, okay, so I had a friend and a former coworker who was working on molds, and like there was it was just cutting metal, right? So it's like CNCing a mold, but there were better ways to like retract pins and do injection points and stuff. There's always that, even in the most like uniform environment of like cutting metal. There's still like better ways to do things. So I think it is just a fact of life. But you're saying just to minimize it so that it is starting from that same everything's metal sort of thing.
Yeah,
Mm.
definitely, and I think to some extent this is volume dependent, right? If you're going to make 5 million units or
Sure,
something,
totally.
you
Yep.
probably want to trade your design time for your
Yes.
production cost. You can, if you can shave 10 cents off, then that's probably worth you spending a few days trying to do that. The
Yeah.
reality of the
Yeah.
situation is most design engineers in the electronics industry are not working on iPhones. They're working on
Yeah. Yeah.
some product that's going to be produced 1,000 times
Relay
over. And
controller.
yeah, it's like a piece of industrial equipment or medical equipment, or
Yeah.
something that's just never really going to be produced in volume. And so the correct trade in that circumstance is often not to optimize for manufacturing costs, but things like accessibility and ability to rework and
Yeah. Right.
robustness of the design, and like there tends to be just like much more important things. And so I think of our job as like let's make it so that you don't have to worry about the manufacturing process as much as possible,
Mhm. Yeah.
and we can just
Yeah.
you worry about all the constraints that we can't control, and we'll just try and adapt to what you want to do. And obviously that's just like an ongoing like tug of war there, right? Because
Yeah.
you get
Yeah.
advances in what's possible on the manufacturing side of things as well. And so any cutting edge process, if you're really trying to push the boundaries of what's possible and sort of do a 24 layer board with multiple layers of micro vias and things, right? There's going to
Oh
be
my god.
design constraints in that. There's
Yeah.
physics gets involved at some point, and so um, it's
Yeah.
just trying to be trying to push as much information to the designer as we possibly can.
Got it. Got it. Yeah. Watch out for those Lucas Henkels of the world, right? You watch
Oh,
his designs
I
on
love that
LinkedIn.
guy.
My
Yeah, it's like
every day. I
brightens
feel
my
like
day every
I
time I
don't know.
see it.
How does he make so many design? I know he's working with the team too, but like, damn, like, wow, every time. Yeah,
So
he's
cool,
great.
right?
He's
Like, yeah, just awesome to look at. Yeah.
yeah, it's eye candy for sure. What about like so people, you were talking about production. So what's the off ramp? I mean, you said startups often still go with you, which is great. What is the now I say, hey, I've got to get to 100,000 units. Where do I go from there? Do you guys shepherd that through to a different manufacturer or over to the Worthington side? How does that work?
Yeah, so we do some higher volume, quite a bit of higher volume work now. The way we kind of think about it is, so we think about it as though we flatten the pricing curve, right? So if you look at like typical electronics manufacturing, to make 10,000 units is very efficient on the unit cost basis, and to make one unit is really expensive. And so because we flatten that pricing curve, we enable people to produce smaller batches. And so instead of making a single production run every 6 months of 10,000 units, we actually just enable you to do smaller production runs on a weekly or a monthly basis, and
Oh,
then
that's
make
interesting.
that
Yeah.
cost effective for you. And
Right. And
so
that's got to be good for you guys too, right? Because then you're kind of feeding the machine and you have this kind of known business. So that's an interesting idea.
yeah, it's a much more kind of, this is what we, when we say on demand manufacturing, that's really what we mean, is to kind of move away from this world of I'm going to make 10,000 units. Like you go through this design cycle where you're making 3 or 4 prototype runs over the course of a year. Those prototype runs are really expensive, and they take a bunch of time, and so you're spending a lot of upfront work on the design side, even just to try and get those prototypes right first time. And then when you move
Yeah.
into production, if you're going to push the button on 10,000 units, it's going to cost you $500,000, $1 million. Like, you've got to make sure that design is right first time. I've had heart stopping moments where I've got $500,000 worth of product in production, and I spot an issue, right? Like, you uncover some issue through you writing code for your microcontroller, and you realize you've mixed up a couple of I squared C lines or whatever it is, right?
That's
And
never, no, no, nobody's ever done that.
never, yeah, it never happened to me. I promise.
Yeah,
But
RxTX, whatever. Yeah.
um,
Fun job.
and so that can be like really scary to scale up into those production volumes straight away. And so really, what we want to see is a world where it's much more gradual. You can just
Mm.
produce a few hundred units, ship those out to customers, scale up from there over time. And so that's really what we're starting to see with our customers, is whereas previously, they may have thought about going to a dedicated production shop, possibly over in Asia. They're now starting
Mm.
to see us as a much more viable option for their ongoing production. And so there's obviously a point at which it makes sense. Actually, what we're seeing is, for the really high volume work that we are not currently capable of doing, we're actually seeing people start to set that up themselves now, right? So
Oh,
the
yeah.
you know
That'll be customer dependent, right? The SpaceXs of the world probably have more resources than, I don't know. I like maybe other manufacturers are doing that themselves, but I've not heard of it personally. You see it
Yeah,
a lot more
it's
than I do.
it's still pretty niche, right? There's very few companies
Yeah.
that are capable of both developing a product and developing a manufacturing process at the same time. And I definitely,
Yeah.
we've spoken to a couple of companies that have considered doing this, and we're just like very open and honest with them about like what's involved, because
Mm.
you look at it and you think, oh, I'm just going to go and buy a couple of SMT machines and it'll be fine. And like, there's a lot more complicated than that. There's a reason these
Yeah.
things are hard to do. But there is
Right.
an advantage to having a facility that is designed to produce a specific product, right? And so if you look at high mix manufacturing in the US, about 90% of the cost of goods sold there is labor, right? So
Yeah.
if you think it's expensive to get stuff made in the USA, it's because it's very labor intensive, because all of these factories are set up to do low volume production across many
Yeah.
customers. And so if you can set up a factory that just specifically makes this one particular product, it can actually be much more efficient.
Yeah.
Um,
Yeah. I mean, Raspberry Pi does a bunch of I think they're partnered with Sony, but I think they do UK, all UK based, or maybe they mostly UK based, I think, right?
yeah, I think it's 100%. It's over in Wales. They make
Oh, cool.
those, and I think it's a great example, like
Yeah.
of being able to do high volume, and they've really gone to town on kind of optimizing that production line for like a single
Right.
product. and
Yeah.
and so hopefully at CircuitHub we're able to take that level of automation, but then give it to everybody, even if you're making 1 unit, 10 units, 100 units. And so yeah, we're certainly starting to see more and more higher volume work, and that's a direction that we want to go in. But yeah,
Mm.
there's a scale at which it either makes sense to make your own factory, or sort of go to a dedicated high volume supplier.
It is interesting thinking about, like, so if I did like a, low to mid volume, and then I'm like, okay, I need to go high volume now, and I go and hire a Jable or something like that, right? That's like a mixed domestic overseas, whatever, right? They don't have just like extra capacity. Like, they're going to spin up a new factory too. It's like they're applying process, but then they're like buying machines and hiring people, but they have the process there as well. So it's like a kind of like you're like buying process from them. Maybe they have some capacity depending on size, but like you said, at some point, if you can learn, it's probably some benefits to bringing it in house and learning that process. But if you can kind of ease your way into that higher volume type of thing, that actually could be very beneficial.
Yeah, I mean
I've
those
actually never.
those big EMS companies are tough to work with if you're realistically, if you're doing like sub 50 million a year. Like,
Yeah.
it's
Don't
hard.
bother.
They're
Yeah.
just they're not geared up to deal with that.
Right. Exactly. Yeah. I don't plan to. But that is an interesting idea of I like before you said it, I don't think I've ever thought of that before as an option. The idea of like this is probably just my stupidness, not that it didn't exist, but like the idea of like kind of that ongoing, just the steady drip of boards weekly, boards monthly. That is a very intriguing idea. I had not thought of before.
Yeah,
I think,
it's
as
kind
you
of
said, it's
the
like
whole to
the
to
cost
some
curve.
extent the
It's
whole
trying to
sort of
optimize the cost curve.
yeah. What when you think of flattening that price curve, like it's not that interesting in isolation to reduce the cost on making 100 units, right? Like, but it becomes like because you think, okay, well, I order 100 units once as part of my scale up process, right? Like I order a few prototypes and then I order 100 units and then I go straight to 10,000, right? So in isolation,
Yeah.
reducing the cost of those 100 units is not that interesting. But if you switch the mental model a bit and you think, okay, well, look, I'm never actually going to order 10,000 units. I'm just going to keep ordering 100 units, 200 units, 300 units.
Yeah.
But I'm still over the course of the year going to be able to achieve similar sort of pricing to if I had ordered 10,000 units. Well, then it starts to get really interesting because you get the benefits of like lower working capital, you get the ability to iterate on the
Yeah.
design, you don't get those heart-stopping moments where you realize you messed up and you've just sunk the business because you got $500,000 worth of boards that you can't use, and so
Yeah. Yeah.
there's a ton of benefits to it.
Yeah. And it does kind of benefit all parties too. Like you said, cash flow, manufacturer likes it. I like it. It kind of does. If it was possible, it'd be good. And maybe that goodness in the short term, short to medium term, it actually makes up for the any differential that would be there from the kind of higher volume. Anyways. So
Mm-hmm.
yeah, it's very interesting. I'd like to. I know we're way over time already, but I'd like to just circle back one more time to just kind of tariffs and domestic stuff because you're kind of on the ground seeing that stuff in the U.S. What what should I do? What the hell, man? Like, what should I do? What are you seeing? What are people doing? Or how is it impacting things? And then people can turn this off if they're sick of hearing about it too.
Look, I mean, it's very unpredictable, right? Who knows what's going to happen with the tariff situation
Yeah.
tomorrow? I believe we're going back to I think it's 50% tariffs from China now as of today or tomorrow.
Well,
So it's
we're
changing.
pre-recording this, so I would say we should just this is probably 2 weeks away from publishing date, so I'd say we should really hedge our bets on that one. Yeah,
Yeah.
but right.
Yeah.
Yeah,
I guess I won't try and predict the future, but I think there's this general there's this general trend uh, to increasing tariffs, I would say, in the US. And so we've seen we've seen certainly uh, a whole new type of customer approaches that we'd never really seen before, and that is companies that make consumer electronics. So it would have historically been very rare for us to have a conversation with a company making like watches or laptops or various wearables, consumer devices,
mm,
because generally they will, because they're made in such high volume, they're generally going to work like an ODM over in China, typically, who are going to help them both on the design side and on the manufacturing side, and then they'll deal primarily with the software and the marketing. Actually, increasingly less on the software side. Actually, they tend to be more marketing heavy operations. Um, but obviously, with the tariff situation, that is becoming less of a sustainable model, and so we're having conversations with these consumer electronics companies about not just prototyping, but like, can we feasibly do consumer electronics manufacturing in the US? And I think it is feasible, actually. Like, is my longer term view. Now, is this something that you can spin up overnight? No, but I think it is something that you can work towards over time. And then the question then becomes, how do tariffs relate to the inputs on that, right? So if you're going to do electronics assembly, well, that is often the final step in the process, right? And so you have a bunch of
yeah,
inputs into that. You have the parts, you have the bare board fabrication, and then you go up a step from that, and you have the inputs into bare board fabrication, the chemistry, the laminate, you have the inputs into the semiconductor industry in terms of power and a lot of chemistry and such. So how the tariffs relate to those things is also increasingly important. So you really need a lot of these the supply chain to be built out like simultaneously, so that you can bring in sort of increasing amounts onshore for it to make sense. So I mean,
so you're going to start chip hub anytime soon? Is that what I'm
a chip.
hearing?
Well, I think there are. Yeah, there seems to be a lot of people working on it, and obviously the US government has invested quite substantially into the CHIPS Act, and there's a lot of fabs
mixed results, I think. But yeah, I think some movement.
Yeah, I mean, there's quite a few big fabs, and I'm aware of at least one company that's working on the sort of chip side of things, and so I think there'll be some movement in that space. So yeah, it's a bit TBD. It depends what happens. I mean, there was that short period of time where the tariffs went up to about 150%, and at that point, like you can't do consumer electronics manufacturing in China, right? Like it's just no longer feasible. And so Apple have rapidly moved a lot of their production over to Vietnam, and I think a bunch of it's going over to India. They're obviously making the bet that those regions are going to get favorable tariff rates. And then I think Apple are looking at onshoring their production. They do.
I think everybody's giving it lip service at the very least, right? We're going to see news articles first, and then 5 years from now, we'll see where they land, right?
Yeah, but SpaceX with this Starlink facility have certainly proven that it's possible, and so if the will is there, it can be done. Whether it's debatable whether you want to drive that through tariffs. I think as somebody who runs a business, you just want stability, right? Like you want the game to be understood. You want everybody to know the rules of the game, and then you just let the businesses optimize around that. And so what's really not good for anyone is uncertainty, right? Like it's incredibly difficult to make investments and plan ahead when things are changing rapidly. And so my hope is we get some more certainty on what's going on, and then once everybody understands the new game, then we can all play to that. But as a general theme, I do hope we see a lot of manufacturing returning to design engineers, right? I'm a design engineer at heart, and I want to be involved in the manufacturing side of things, right? Like I think that's fun, and it provides a lot of inspiration, and so I hope to see that happen one way or another.
I got my start at Keithley. I got to walk out to the pick and place line, and have an engineer be like, this was a bad idea. Like there are benefits, like you mentioned earlier, like there are such benefits from that. I don't know if this is how we get there, but like I am all about it. Like I think it's great. I think having quick turn in country, like that stuff is awesome. I just I don't think the current path is it, but maybe there will be some tack-ons that help. I don't know. Yeah, so it's interesting to hear how the kind of the customer mix for you has changed. That is very interesting. We'll find out. Well, when this is published, I don't know if we'll have any updates on it, but we'll
all see. I wouldn't want to place a bet on it right now. I think we'll just have to see how it pans out.
All right. Well, Andrew, thank you so much for being here again, 12 years later. I'd say let's check in less than 12 years. What do you think?
I think so. Yeah. No, this has been fun, Chris. I appreciate you taking the time, and let's not leave it so long next time.
Great. Well, people can find you at CircuitHub.com. Anywhere else that people should look to see your latest stuff?
Yeah, that's the main thing. CircuitHub.com, and you can see some links to some of my content on there.
All right. Well, thanks again for being here, and we'll chat soon.
Thanks, Chris.